Hello everybody, and welcome back to Mr. Anderson's Algebra 1 lessons. Today we're going to take a look at solving some multi-step equations, and we're going to build off of multi-step equations, and we're going to build off of what we talked about in solving single-step equations. So a lot of the same principles follow. We use SADMEP, inverse operations, reading the equations, algebra's golden rule, which is what you do to one side of the equation you do to the other. And we're kind of just going to jump right into solving these guys. And so I'd like to let's start off with this equation here. Let's do a little bit of the easy one. Let's do 5 plus n divided by 12 is equal to 1. And so what we're going to do here is we're going to solve this multi-step equation. We're going to use some inverse operations as well as algebra's golden rule. What you do to one side of the equation, you do to the other. Now, when I'm taking a look at this equation, I know that I see there's an addition sign, so I'm going to have to do the opposite of that, which is subtraction. I also see that we're dividing here, so the opposite of division is multiplication. Now, a lot of you might want to move the 5 over to the other side of the equation, but we can't do that yet because this whole expression is being divided, and that division sign acts as a grouping symbol. So all of this is kind of grouped together. So the first thing we have to really take care of is this division sign. And the opposite of that division sign is multiplying. We're going to actually multiply by 12 to each side. And that's going to cancel out those 12s, and what's going to be left over is 5 plus n is equal to 12, because 1 times 12 is 12. And next, I'm going to isolate the variable n by moving the 5 to the other side. Now, since this is a positive 5, I'm going to subtract it to the other side. And I find that n is equal to 12 minus 5, which in this case is going to be 7. Now that is my answer, but how do I know if it's true? Well, one thing you can do is you can take this 7 and plug it back into the original equation. So I'm going to do that off to the side over here to kind of prove to you guys that n does really equal 7. And so the original equation said that 5 plus n divided by 12 is equal to 1. So I'm going to put in my 12 down here. It's going to be equal to 1. And my n, I'm going to replace the n with 7. So 7 is going to go here. Well, 5 plus 7 is 12. So that would give me 12 divided by 12. And I know that 12 divided by 12 is 1. So 1 is equal to 1. And that checks out. And that's a multi-step equation. It's a mathematical statement of truth that that works out, and I proved it by plugging the variable back in, and I solved it. 1 does equal 1. And that's really all you're doing here. So let's try another one here. Let's take a look at, I don't know, let's say we have a little more difficult one here. Let's say we have negative 17 plus 9b is equal to negative 269. Oh my gosh, where the heck did you get that, Mr. Anderson? That's crazy. Oh, just bear with me here. Okay, so how I would read this if I was trying to solve this, I would say that negative 17 plus 9 times some number is equal to negative 269. So again, same principles apply as the one above. I'm going to start by doing the inverse operations to get get this v by itself over here. So what I'm going to do is I'm actually going to add the 17 to the other side over here because those are going to cancel out, and I want to begin to isolate the variable. So I know that negative 269 plus 17 is actually negative 252, and that would leave me with 9v over on this side. Okay, and then when I divide by 9, because this is what you do to cancel out a multiplication, the opposite of multiplication is division, so you divide by 9 here, those cancel out, and v is going to equal negative 28. Now, why I divide here is because the 9 and the v are multiplying, and so when you multiply, to get this v by itself using inverse operations, you're going to actually divide by 9 on both sides. And so v is equal to negative 28. Now to prove that, I'd simply take my statement back here, negative 17 plus 9, and I found that v was negative 28. So I'm going to put that in there like this. And I'm going to prove that it's negative 269. So negative 17 plus 9 times negative 28. Well, 9 times negative 28 is 252. Negative 252. So that's what we have there. Equals negative 269. Okay. And so now I just combine my terms and I get negative 269 is equal to negative 269, and that is true. Okay, so I hope you learned something from solving multi-step equations here. The big ideas are to continue to use inverse operations where they apply, which means using the opposite when you're solving. Double check your work by plugging your variable back in to make sure your statement is true, and continue to like, comment, and subscribe to my videos, and come back for more if you have any other questions. Thanks for stopping by. This has been Mr. Anderson. Have a nice day.